Okay, this video is on what we discussed in class. It's a rehash of it. We're looking at a diprotic acid and we want to determine the concentration of all the species in it. And so, as you know, H2A will dissociate with water in water to give us HA minus plus H3O plus. And we do a nice table with this, and I have 0.1 molar dash 0 minus x and x 0.1 minus x dash x and x. Now this is what we did always before. The problem you run up against now is the HA minus goes on to react with water, and you have to solve systematic equations on this. I get A minus 2 plus H3O plus. So as the HA minus disappears down here, it's going to force this reaction to go. But on the other hand, I'm going to be making H3O plus, which is going to force this to go backwards this way. So it's really complicated. Removal of HA minus makes it go this way. Adding H3O plus in the second reaction when it goes this way is going to force it. So the sum net effect of all this is this reaction doesn't go very much, and we can assume the amount it goes is essentially 0 compared to the value of x on there. So with that assumption, we're going to just solve up here. Ka1 is equal to x squared over 0.1 minus x. And when you solve that, I had to do successive approximations. I had x equal 0.00311. Okay, and so now I can bring it down here, and x is equal to the concentration of H3O plus, and it's also equal to the concentration of HA minus. So I can actually start my table here. H3O plus equal 0.00311. OH minus, which I get from KW, is 3.215 times 10 to the minus 12th, if I didn't make any math errors. HA minus is equal to 0.00311, and H2A is going to be equal to 0.1 minus 0.00311. Remember, I have that going on here a little bit, okay? And so that gives us 0.09699, I think, if my math is good. There. H2A is both of those. And so the last thing I have left to do is to solve for A minus 2. And so I have HA minus is 0.00311, and H3O plus, I've got my plus sign in there, is 0.00311. Okay, and we have dash and 0 minus x, x and x, so 0.00311 minus x dash x and 0.00311 plus x, and I get Ka2. I'll solve it down below here. Ka2 is equal to 0.00311 minus plus x times x divided by 0.00311 minus x. My assumption is 0.00311 plus x is approximately 0.00311, and that's up here, and 0.003 0.0311 minus x is 0.00311. And so if I make those assumptions and they're good, x equal Ka. And so what was Ka? I forget. 10 to the minus 8th. So Ka is 1 times 10 to the minus 8th. And so x equal 1 times 10 to the minus 8th. And that makes our assumptions clearly good by a large margin. And so a minus 2 equal 1 times 10 to the minus 8th. I'll expect you to do that. I'll expect you to state, which I didn't do here, state your assumption and assumptions, and are they good? If I do this problem during the titration, you won't have to do that. You just have to solve. All right, I'm going to stop this. Bye-bye.